So let's talk here. I have two graphs. We'll go through and see what you and your partner came up with to talk about. So what is similar? What is different? Isaiah and Zane, tell me one thing you talked about. Okay, can you tell me which one goes up, which one goes down? The one on the left side goes down. So I'm going to say the one on the left, oops, the left, it opens down. And the one on the right opens up. Ben and Nick, what was something else that you noticed? Ah, they are both non-linear. Very good. Cole and Caleb, what did you talk about? What do you mean? Okay, so it starts negative. So the right starts negative. And I'll say a negative x value. And moves.
Mr. Ford, please report to the main office.
Positive. What else did you notice, Dante and Cyrus? Okay, you're right. Anything else that you notice? You're correct. That's not so much what I'm looking for. What do you mean? Okay, so in different quadrants. Juan and Kyle, what did you talk about? Okay, did anybody else get anything different? Nick? Okay, they are both quadratics. That's what we've been talking about specifically. This U-shaped upside down or right side up, that is what we call a quadratic, and the shape of it is a parabola. Those are the words, again, that you would have noticed when you did your definitions yesterday. Okay, so we're going to be talking about specific properties about these quadratics. Okay, so if you can turn to this because you have this in your notebook. Kyle? You should have this. You were here, no, you were here and you got it. Because you were here on Monday. Okay, so if you have some different colors here, I'd probably be using them. If you can, we're not going to use the graphing calculators just yet. What we are going to do is we are going to talk about some keywords, which you should have been exposed to yesterday when I asked you to copy out your definitions. So we're going to talk about here, I have the vertex. This is a new word. The definition of the vertex is the maximum or minimum point on the graph. It's the point where the graph changes directions. So, how do we label this? Your answers, whenever I ask you for the vertex, will always be x, y. So, on my graph here, I'm going to get Paul and Noah. I want you to walk up to the front, and I want you to, Paul, you're going to do graph A. Noah, you're going to do graph B. Actually, no, we're just going to do graph A. Paul, I'm going to get you to walk up. I want you to put your finger on the maximum or minimum point on the graph. It's the point where the graph changes direction. Where do you think you would point for that? Where is that? Beautiful. So I want everyone to draw this point in right here. This is our vertex. It will be a maximum or a minimum point. Now, it says here that I have to label this x, y. So Noah, how would I, what coordinate value would I give that? What is this point right here that we do the vertex on? So I label it x, y. So instead of me putting x, I'm going to put a number. And instead of me putting y, I'm going to put a number. Very good. 4, 0. So please copy that down. Okay. The next one we have here, the maximum or minimum value. Well, technically we can tell the graph will either only have one or the other. It will either have a maximum or a minimum value. And it's where it occurs on the graph. So you have to look at the graph and decide, is there a maximum point or is there a minimum point? So again, here that's what will kind of help us out here when we do this. So the maximum is the largest y value, and your minimum is your smallest y value. You will only have a maximum or a minimum. You can never have both. How do we label this? We will label this y equals, and you will fill in the number. So there's a couple of ways you can do this. If I look on this graph here, will I have a maximum or will I have a minimum? What do you think, Hannah? Yeah, it always occurs at the vertex. So I'm going to write here beside my vertex, this is a minimum. And it's always in the form y equals. Well, what is the y value when I look at this? Isaiah, can you help me out? What's my y value here? Very good. So I'll just write up here, y is equal to 0. Okay, the next definition, again, which you can have here, the axis of symmetry is a vertical line that passes through the vertex. The equation of the axis of a symmetry, so how do we label it? Well, we will always label this x equals. So your axis of symmetry, if I go back to my graph, is a vertical line Let's see. It's a vertical line, so vertical goes up and down, and it passes through my vertex. So here, so I'm just going to kind of color code this. There is my vertex. Or sorry, not my vertex. It's a vertical line that passes through my vertex. And we say that this here, so that line, represents the axis of the equation. Or sorry, the axis of symmetry. That's where that is. The axis of the symmetry is right in the middle. It splits it so that if you were to fold your parabola, it goes right, it's a mirror image. So, Zane, what do you think I would put, oops, what do you think I would put here for graph A? X equals what? X equals 4. Wonderful. Now there's a nice pattern here to get my minimum and my maximum. As long as I have my vertex, if you look, my vertex here, my y value is my minimum. My x value is my axis of symmetry. So your vertex tells you lots. Okay, another piece of information that we can find, sometimes it's easier than others, is the y-intercept. And we actually know how to find the y-intercept from our linear equations unit. So the y-intercept is the vertical number line on the, oops. Okay, I'm sorry, I messed this up. I'm copying the wrong thing. Just kidding. The y coordinate of the point at which the graph crosses the y-axis. So we label this as a point. So on here, I'm going to use, let's see, purple. You will label it as a point. Your y-intercept will always be 0 and then some number. That's how we do our y-intercept. So if I look at my graph A, Nick, where is my y-intercept? Oops. Where's my y-intercept here? So 1, 2, I'd say that it's here. So that's 1, 2, 3. This is my y-intercept. So I'm going to say that that's about halfway. So we can fill that in our chart and write 0 and then about 3.5. So here we will write 0, 3.5. Okay. The next one that we'll do is the, so again, I'm going to try and simplify this. It's where the graph crosses the x-axis. And you'll always write that as something 0. Now, if I look at my graph, I'll give you a second to kind of copy this down. If I look at my graph, Ben, where is my x-intercept? Good. So here is actually also my x-intercept. So when I write that in my chart, I'll write that as 4, 0. Okay, and then the last one here, zeros, it's just another way of saying x-intercepts. The x-intercepts of the quadratic. And again, the same thing, you'll always label your x-intercepts as something 0. So again, it would be actually the same thing here for 0. Okay, so again, when I go back to my graph here, this is my x-intercept. I'm also going to put here that that's my 0. Does anyone have any questions with A? Okay, let's do B together. So again, these are words that you have to know. I'm just going to try and make this a little bit easier so I don't have to flip back and forth because you have this all on the same page. Okay, so let's see. Here's my graph B. I'm covering up the definitions, but I think we can live without it. Okay, my vertex at graph B. Ben, what is my vertex? Or no, sorry, Cole, what is my vertex for graph B? Pardon? 3.5 and 6. So again, I'm going to label that up here. Here is my vertex. I would like you to do the same thing. Now, do I have a maximum or a minimum here, Caleb? Very good. So I have a maximum. So I'm going to write maximum here. And what is the maximum value? How do I write that, Caleb? Y equals what? Excellent. Dante, my axis of symmetry. Where is that? Pardon? Pardon? What is it? How do I write it? Look at the A example and tell me what would it be here. Okay, now can you tell me how would I write that answer? Okay, so you have it in the correct spot, but I want to fill something in my chart here. What do I write? Okay, so what will I write here? No, I'm not going to write 6. Look at your example that we just did. How do I write it? Which is another way of saying how do I label it? x equals 3.5. Dante, are you okay with that? Okay, Cyrus, my y-intercept, where is that? Very good. This is my y-intercept. And it occurs at 0, 2. My x-intercepts. There's more than one here, and it's okay to have more than one. Juan, can you give me one x-intercept here? What? No, that's not how I label x-intercepts. Look at your, pardon? No, 8, 0. So this is one x-intercept. And that occurs at 8, 0. Kyle, can you give me the next one? Negative 1, 0. So I have another x-intercept. Okay, and the zeros are actually going to be the same thing because zeros and x-intercepts mean the exact same thing. So I'll write here 8, 0, negative 1, 0. Are we okay with this terminology? Anyone have any questions right now? Okay. The next question we're going to do, I didn't even write it in. I'm going to show you how to use this on your graphing calculator. So the next page in your workbook, I believe, is blank. Can you please copy this example down? I'll give you a moment to copy that down, please. Okay, so you should have this all copied out. If you want to open up your graphing calculators, I'll go over the sequence of how awesome this graphing calculator is because it really tells you everything. So, and you're going to have a couple questions like this in your homework where you have to use the graphing calculator. Okay, so our first step is we have to enter in we'll turn on our graphing calculator. We have to go to New Documents, and we're going to add a graph. How many of you have this screen on your calculator? Raise your hand. Okay. If you do not have it on your screen and you need help, please raise your hand because I'm going to be moving on to the next step. Are we okay? Okay, let's enter in the equation. So we have f1x equals, so we put 2x squared minus 4x plus 6, and then we hit enter. How many of you got a picture that looks like this? Did anybody not get this picture? Please raise your hand. You put 52x. So you got to fix that. So go to a new page and change it. Okay, new document. So hit enter. You have enter here. You can click it there. Doesn't matter. Okay, you're going to go to new graph. You're going to add a graph. Okay, and then now you enter in the equation. squared. You should have it here. Minus 4x. Yep. Plus 6. And then enter. Okay, are we okay? Did you get it?
Oh, yeah.
Okay. Does anybody else not have this picture up? Because I'm moving on to the next step. You are going to have to do this on your own. Okay, so what we want to do next is we want to zoom in a little bit. So remember, we go to Menu, Window Zoom, and then we're going to zoom in. Now you can click on here and it zooms in. Ooh. And you can kind of drag up to see the graph here. So is everyone zoomed in on their graph? Does anyone need help zooming in? Nobody needs help because I'm going to move on. Okay,
Yeah,
did you?
zoomed out.
No, zoom in, Ben. Anybody else need help zooming in? Isaiah, he's got to do it on his own. So you press it there, and then you kind of so if you kind of just hold it and then move it down, like it'll shift down, okay? Does everybody have it? Is everyone zoomed in? Are we okay? Ben, are you okay? Okay, the next step with the graphing calculator. And this is really cool because it tells you everything on here. You just got to be patient. So we're going to hit Menu. Then we are going to hit Trace, which is number 5. And then we want to hit Graph Trace. How many of you have something like this? Okay, what you can do is now use your cursor. You're going to use your arrows. So as I use my arrows, I'm going to try and, okay, as I use my arrows, so here's my arrow here. As I follow along, just watch mine. Look what happens when I get close to here. When you get here, I want everyone to kind of get there. Does your screen say something? What does it say? Oh my goodness, it just told you what y-intercept. So you don't really even need to think when you use the graphing calculator. So the y-intercept, and look, it actually even gives you the coordinates. It gives you the answer right there. The y-intercept is 0, 6. So you can put that in on your question sheet. We know what the y-intercept is now. So again, if I go back, oops. If I go back here, my y-intercept is 0, 6. Okay, now, when I go back to my graphing calculator, I'm going to continue to scroll down. Scroll, 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 until something else pops up, which gives you what? The minimum. How many of you have the word minimum that appeared on your graphing calculator? It should appear at 1,4. So if you're not on 1,4, it won't say it. Okay, so then you kind of got to look at your graph. It should say it. Your minimum. Okay, now just hang on. This actually isn't your minimum. It's where the minimum occurs. But this point here, 1,4, is telling you what your vertex is. So if I go here, my vertex, I have a minimum, so I'm going to circle minimum. My vertex here was what again? I forget. 1,4. Okay, so my minimum occurs at y equals 4. So you're using that reference sheet to always tell you how to write it. Now, I have to find here the equation of the axis. Okay, your graphing calculator won't tell you that, but you should be able to look at that and tell me what would you write down for the equation of the axis? What would you write down? Look at our example before. What would you write down for our equation of the axis if this is our graph? Isaiah. I want just the answer. What would you write? No. If I look back at my note, whenever I wanted the x-intercept, or sorry, the equation of the axis, look how I wrote it. Equation of the axis. So what do you think your answer would be? X equals 1. Very good. So we'll write that in here. My axis equation of the axis is x equals 1. Now, identify the x-intercepts. Okay, so watch my graph here. You don't have to do this. Okay, can anyone tell me where does this graph cross the x-axis? One? It doesn't. So what can I write down here? There are no x-intercepts. So we've looked at example now where we had one x-intercept, we have two x-intercepts, we have no x-intercepts. So you could have a couple different answers for or from there. Does anyone have any questions right now? Okay, so your homework, I'm going to give you some worksheets that you will need to complete as well as some textbook work where you will use your graphing calculator.